Hello, friends, and welcome to a lesson with many sides. Of course, I'm referring to polygons. What are those? We're about to check them out. Well, let's start with the word itself. Check it out. Polygon. The word polygon actually comes from two older Greek words, poly and gonia. Poly means many, and gonia means angle. Many angle. Polygons, so any kind of shape, a closed shape that has many sides. Let's check a couple out. You might know this one pretty well. What's that called? Of course, it's a triangle. It doesn't even have the word "gon" in it. But it does have the word angle, and it does have many angles. Tri actually comes from the Latin word tri, and angle comes from the Latin word angulus, which means corner. A triangle is literally something with three angles. How cool is that? But what happens if we add another side? We end up with this one right here. You're saying square right away, but what if the sides weren't equal? It would have a different name then, wouldn't it? Quadrilateral. That is quite a word. It also comes from several parts. Let's talk about those parts. The quadra comes from the word quator, which is Latin for four, and lateralis, which is also Latin for side. And this is a regular quadrilateral known as the square because its sides are equal. All right. But what happens if we start adding sides? We'll end up with a polygon that looks like this. This one has 1, 2, 3, 4, 5 sides. We call it a pentagon. Penta comes from the Greek pente, which meant 5. And of course the gon coming from gonia, which means angle. 5 sides, but also 1, 2, 3, 4, 5. 5 vertices or angles. That gives us a pentagon. Let's add another side to that pentagon and it becomes something brand new. Another polygon. And this one has 1, 2, 3, 4, 5, and 6 sides. Wait, how many angles? 1, 2, 3, 4, 5, and 6. 6 angles, 6 sides. We call this a hexagon. The hexa comes from a Greek word hex, which means 6. And you know about the gon part. So let's add some more sides. We had 6. How about 7? And this one's fun because look, it has that flat bottom and that point, but we could also turn it and have it balance on that point. How cool. This 7-sided polygon is called a heptagon. And hepta is Greek for 7. It's a 7-sided, 7-angled shape. How cool. All right, I've got another friend here. Ooh, go ahead and count the sides on that one. Don't stop. There's 8 sides and 8 angles on this one. We call it an octagon. And an octagon, well, the octo comes from the word octo, which means 8. And again, you know that gon part, gonia, meaning angle. It also has 8 angles. How fantastic. You might even know of some other things where oct comes into play. So it makes only sense that we move to a 9-sided polygon. And there's that one that either sits on a base or might even balance on one of its vertices, depending on how you see it. This is called a nonagon. Not notagon, nonagon. From nonus, meaning 9. And this polygon has 9 sides and 9 vertices. It's a nonagon. So it makes sense we add yet another side. Can you count the sides on that one for me? There's quite a few. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And how about the vertices? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 sides, 10 vertices or angles. This is known as a decagon. From deca, meaning 10, and that's Greek. You may know some other things that have that deca or even a dessa in them, and that also means 10. These are all regular polygons, which means that all the sides and angles are equal. But we could have ones that aren't so regular. Here's some irregular polygons. Oh, this one's an irregular pentagon, and you might even recognize it if I add a couple things here. There we go. Fantastic. Yes, that's right. What a cool looking irregular pentagon. And then I'm not sure what this is, but 1, 2, 3, 4, 5, 6, 7, 8, 9. It is an irregular, that's right, nonagon. Maybe it's like an asteroid or something. How cool is that? Well, there's one more really interesting thing I want to show you about these. Let's go back to our pentagon. I'm going to actually take this pentagon and put it right inside that circle inset. I want you to look really closely at the space around the sides. This is a pentagon, right? 5 sides. Let's switch it out for our hexagon. Take a look at that space. What are you noticing? I'm going to move on to the heptagon. Look at that space. Of course, the next one will be the octagon. Look at the space around the edges. What's happening to it? Let's move on to the nonagon. Look at the space. And last but not least, but mostly because I don't have any others at the moment, the decagon. But I want you to use your imagination now and imagine 11 sides, or 12 sides, or 13 sides. What would happen to the space? It would decrease, wouldn't it? It might even eventually, if we add enough sides, look very much like this. Oh. But that's a circle. Or is it a polygon with infinite sides? Would have been cool if there was a clap of thunder and some lightning, right? All right, let's get on to some follow-up. You've learned about all sorts of polygons today, and now I'm wondering, can you find any of those polygons in your own environment? What you'll need to do this work is a piece of paper and a pencil. Go ahead and copy down all those names of polygons, and you can start with triangle. Once you have the name of the polygon down, go and take a look for those different polygons around your house and outside. Some might be more common than others, but how cool would it be to find one of each one? So leave yourself some space so you can make sure to include the other polygons you learned about. So triangle, and I'll skip down several lines, and write the quadrilateral. And what was that next one? 5 sides. Oh, that's right. The pentagon. Oh, that's right, the hexagon. And you could go back and watch this video if you've forgotten some of those, and try to make a list of all the different polygons that you've found. I expect to see some really interesting polygons in your list, and I already know that you might have stopped at one that you recognized. Well, Geometric Explorers, I can't wait to see what you find. Have a fun time searching.